pick up right where we left off yesterday. I'd ask you guys to do a couple of these for homework, so we're going to go over those first, and then we'll go over some of these other questions. There won't be much new stuff today. It's mostly just going to be a review of what we've been doing the last few days. I know I just got a couple more email addresses, which means you guys are like 3 days behind. I've been taking it pretty slow, so you can kind of work at your own pace. You could do a page each day and whatnot. I will, some point, I think I put the answers on the website, but if you guys want them, I'll post the answers up there for you. So if you're having a hard time following this, go back and watch the last few days' videos, and I'll explain all of them. So today is pretty much just a work day. We're just going to go over a few problems, and then you guys are going to do a few on your own, hopefully. So this last problem was talking about nails. I still have the numbers filled in yesterday. It says the length of any given nail is normally distributed with a mean length of 5 inches and a standard deviation of 0.03 inches. So I still have the numbers up there from yesterday. So your mean is 5 inches, and it's plus 0.03 going up and minus 0.03 going down. So they want to know how many are between 4.97 and 5.03, and that's out of 120 nails. Well, that's one standard deviation above and one standard deviation below. So luckily for us, that's kind of given to us. That's 68.2%. So 68.2% of, where's my pin number? Come on, pin. There it is. So again, it's 68.2%. Well, the first thing you need to do is you need to convert that to a decimal. So that's going to be 0.682. Again, if you've forgotten how to do that, you just divide it by 100. 68.2 divided by 100, or percent per 100. Okay, so 0.682. And again, if we want to find how much of 120 nails that is, it's 68.2 or 0.682 times 120. So all you need to do is take that number and multiply it times 120. And so 81.84. So it's 81.84, or about 82 of the nails. Okay, which is a good number, right? Just for quality assuring purposes and things like that, you want most of your nails to be within one standard deviation, and they are. It says find the number of nails in a bag, 120, that are over 5.03 inches long. Well, that's one standard deviation above. Okay, so again, I need to know this part out here. So as we were doing the last couple days, well, it's 50% up to the middle, and then another 34.1% here. Now what we're going to have to do is, if this whole thing is 100%, and we want to know this part, we're going to take the 100 minus the 50 minus the 34.1. Okay, so we're going to do 100% minus 50 minus 34.1. There's a couple different ways you could have done it. You could have said, all right, well, what's 50 and 34.1? It's 84.1. Let's subtract that from 100. Okay, but no matter how you kind of slice it, there's 15.9% here. Okay, so 15.9% here. And again, watch these numbers because they don't add up to 15.9%, because remember, this keeps going out to infinity. So 15.9%. So what do we got? We got 15.9%. What is that? That's 0.159 times 120. Okay, so once you get the percent, you're just multiplying by the number in there. 0.159 times 120 is going to be about 19 nails. Okay, so we'll say about 19 nails. Good. So that was your work last night. That's all you need to do. Like I said, if you're having hard times with these, I haven't got any questions, so I assume it's going well, but just in case. Okay. So today we're going to go over questions 20 and you can delete this page. And 21, and I'm going to leave you guys to 23 and 24. Don't freak out that there's 6 parts to these questions or 10 parts to these questions. It's fine. You guys, you're just finding the percentages, and then you're finding this right here, okay? Okay. Says the actual weights of a bag of pet food are normally distributed. The mean of the weights is 50 pounds with a standard deviation of 0.2 pounds. Use the graph for A to C. You don't really need to use this graph, but let's go ahead and let's kind of see what we know. Well, if the standard deviation was 0.2, so here's my mean, right? And here's one above the mean. Here's one below the mean, right? This is one standard deviation each way, right? And this would be another 2 standard deviations going this way. So again, what do we do? The same thing we have been doing, okay, is this is their mean, okay, and they label it mu. And this was +1 standard deviation, and this is +2 standard deviations. Okay, so this is -1 and -2. Okay, so again, in here, we're gonna have 34.1%, and on the outside, we're gonna have another 13.6%, and then after that's gonna be everything else, okay? So about what percent of bags of pet food weigh less than 49.8 pounds? So they want this over here. So about what percent would be on this side? Well, again, same thing, you guys should be fairly familiar with these numbers, 50% and 34.1%, right? So 50%, right? Half the bags have more than the mean. And then 1%, 34.1%. So since all they wanted was less than 1 standard deviation, what are we going to do? Okay, well, there was 50% and 34.1%, so that would be, if we want to know what's less than that, we're going to say, well, 100% is the whole thing, minus the 50% that was 1 standard deviation bigger, minus the 34.1% that, I'm sorry, this was the entire right-hand side, right? This whole area over here, all the ones that were bigger, minus the 34.1% that was 1 standard deviation smaller. And that would give us whatever is remaining over here. So again, what's 100 minus 50 minus 34.1? Again, same thing we've been saying, is 15.9. So about 15.9% should weigh less than 49.8 pounds. In a group of 250 bags, so they're giving you the number of bags, how many would you expect to be more than 50.4? So how many are going to be up here? So it should be a smaller number, right? But it's the same idea, guys. If we had, again, 50% brings me to here, right? And then we had the numbers we should be getting familiar with, 34.1%. And then is it 16.2? No, sorry, 13.6. So 34.1%, another 13.6. And this is what we're trying to find, the bigger part. So what we have to do is we have to take the 100%, which is the whole, and subtract these numbers from it. So let's say 100 minus 50 minus 34.1 minus 13.6 and see what's left over. Whatever's left over is all the way on the side of the graph. Okay, so we got 100 minus 50 minus 34.1 minus 13.6. Okay, what did you get? 2.3%. Okay, so what's 2.3% of 50.4? So let's move this over a little bit. So again, first thing, 2.3% is 0.023 divided by 100. We're just going to multiply that times the 250 bags they gave us. So it's going to be 250 times 0.023, and that's going to give you 5.75. So about 5 or 6 bags. So about 6 bags. Okay. And again, quality control, right? If you're the people running the dog food company, you can't be giving out free dog food, right? So again, just, you have to kind of watch those things, and, those things like weigh every 10th bag just to see what it is, and, just to kind of get an idea of where they're at. Okay. So as a group of 50 bags, how many would you expect to be within 1.5 standard deviations of the mean? Okay. So this is a little bit of an introductory kind of question. Don't want to get too much into half standard deviations yet, but we can. So if you had a half a standard deviation away, here's the tricky part. It's not going to be the same amount. So I'll give you guys an idea of how this works, but I'm not going to go over the crazy numbers. We need a different chart for it. But just so you know, you can have a half a standard deviation. Like I said, we'll kind of go over that as we come to it. So half a standard deviation should be, about here. These should be one half standard deviation, 1.5, which they were asking about, will be out here. But the key thing to note is that this side of the standard deviation is bigger than this side, right? Like this one, again, kind of encompasses from here, like this portion, this higher portion, and this is lower. So you can't just say, all right, what's half the 34 and just kind of split it in half. It doesn't work that way. So we will leave this. I don't want to cover too much new stuff today because I know you guys still got to play a little catch up. So let's leave this off for today, and let's talk about a few of these other questions. Okay, so you can skip that. Okay. So in the accompanying diagram, the shaded area represents 95% of the scores in a standardized test. 95% of the scores in a standardized test. So again, these are numbers that we should start to be, a little bit familiar with. So press this correcting up. These are not things that we should be. Oh, what are you doing, man? No, that's Errol's email. Sorry, guys. Errol, by the way, you're getting emails from now on. Sorry, I was trying to copy and paste it. Didn't work. Okay. So, where my questions go? There. Okay. So this is in the accompanying diagram, the share. So 95%. So that's 2 standard deviations out. Yes. Okay. Again, just kind of approximating it. It's about 2 standard deviations out. So again, these numbers represent 2 standard deviations out. So what's the mean? Well, first of all, you know that if everything is equally distanced, right? The mean has to be halfway between these two numbers. So what's halfway between 78 and 92? Well, there's 14 numbers in between 78 and 92. And so it should be 7 more than this number and 7 less than this number. If not, guys, how do we find halfway between two numbers? We're going to take the average. So if you take those two numbers and you divide them by 2, what do you get? 85. 85 should be right in the middle, which again is 7 above 78 and 7 below 92. Okay. Oh no. Okay, so what's the mean? Again, halfway between those two numbers is going to be 85. What's the standard deviation? Well, again, now we have to do the same thing. Well, it should be halfway between these numbers. This was 2 standard deviations. So they want to know what's 1 standard deviation. Well, same thing. Well, what's halfway between 85 and 78? And again, 85 plus 78 divided by 2 is, oh my God, 85 plus 78, that number divided by 2 is going to be 81.5. So again, 81.5 is 3.5 away from 85 and 3.5 away from 78, right? If I add it to 85 and add, so again, so what's your difference here? 7 plus half is 7, it's 3.5. So what's your standard deviation? It's going to be 3.5. So again, from that, you can figure out the other numbers if you'd like, okay? So again, this is some more stuff we'll be covering. You guys should be able to do 22 with no problem, okay? Draw and label the normal distribution curve. What percentage of boxes contain 104, 110, 108, okay? So you should have no problem with these, okay? This picture is on the website. If not, you just Google standard normal distribution, okay? And it'll bring you something like this with the numbers on it. And draw this as a height supply. So you guys should be able to at least create the graph and draw it. And you guys should be able to tell me about these numbers here. If you're having hard, this is working a little bit backwards. So if you're having a hard time with 23, don't worry about it. We'll go over it tomorrow. But you guys should at least be able to label out the graph, okay? So definitely for sure tonight, I want to see 22 done, and at least 23 the graph label. If you think you can handle this, go ahead and give it a try and send me questions if you have it, okay? So yeah, good luck, guys, and please send some questions and we'll go over them. Thanks.